Hello guys, this is officially my third video that I make on English, so I really hope that everyone who is looking to me it's okay with it and enjoy this content. And we are solving, or we are going to solve the problem 17 of a math Olympiad in Mexico in their statal phase or regional phase as well. Both are exactly the same thing. And the problem says the following, okay? An artist has made an sculpture of, or rock sculpture in form of a rare polyedra. The surface of the sculpture it's made by 31 triangular faces, 18 quadrilateral faces, 11 pentagonal faces, and 7 hexagonal faces. And the problem asks to us for how many edges the polyedra has. In this case, the problem seems too complicated, but if we start drawing a polyedra, we simply notice some basic facts who help us to solve the problem, okay? For example, let us consider the following polyedra, okay? It is a pyramid. Let me draw better, but it's supposed to be a pyramid. Okay, let's move this one to this side, this another one to here. Okay, let's move this pyramid. Okay, just to be more clear with this drawing. Okay, the drawing is not the best, but I'm doing what I can. Okay, let's move this one to this side, and finally this. Okay, the draw isn't too clear, but the key point is the next. Okay, in this polyedra, this is a polyedra. This is a polyedra P. In this polyedra we have how many faces? 1, C1, C2, C3, C4, and C5. Okay, we have 5 faces. But the point, or the key point, is we are looking for edges. Okay, let us focus on one edge. For example, this edge. Okay, this is an edge, but notice that there are always, for each edge, there are exactly two faces that share this edge. For example, for this edge blue, this edge, it's basically the intersection of the faces C1 and C2. Another example is this other edge, the red edge. Okay, let me write in red. Okay, red edge, it's equals to C3 intersection C2. Okay, so okay, the interesting observation is, or the key point is every edge on a polyedra is share or is the intersection of exactly two faces, and that's the key point. Okay, so the problem is quite easy now with this observation because it's enough find the total number of edges of the polyedra and divide such number by 2. Okay, because of our key point. Okay, so but it's more easy now because we already know the number of faces of the polyedra, and let's write down that number. 31 triangular faces, 18 okay, 18 quadrilateral faces, 11 pentagonal faces, and 7 hexagonal faces. So for each triangular face we have 3 edges, for each quadrilateral face we have 4 edges, and for each pentagonal face we have 5 edges, and for each hexagonal face we have 6 edges. So the total number is 3 times 31 in the first case. Okay, in the second case it's 4 times 18, 5 times 11, and 6 times 7. Okay, let's calculate those numbers. 31 times 3, 31 times 3, it's 93, and 18 times 4, it's 72, this is 55, and this is 42. Now let's zoom out those numbers. Okay, 93 times 55 times 93, 72, we have 262 faces, 262 edges. Now let's divide this number by 2. 131. Then the correct answer is D.